Thanks again, Adam, and yes, welcome to everybody to the second panel. As Adam said, energy transition and renewable integration. So I'm delighted to welcome the panelists, and if I can go through them, probably well as I see them on my screen at least, and I hope you see the same order as well. So I'll go around the table. So Mathieu is a public and relations advisor for Elia, based in Brussels. Graeme Cooper, the head of future markets at National Grid. Daxita, Rajcoomar is the chief sustainability officer at ENGIE, based in Dubai. Jenny Taylor, good morning to Jenny. Very early morning for Jenny in Charleston, South Carolina, who is the digital transformation and innovation lead at Duke Energy. And across the water to Oslo, Guro Knapstad is the innovation lead and energy transition at Glitre Energy, as I say, based in Oslo. So welcome to the panelists. What a fantastic lineup we have here. What I'd like to do is start with the sort of, I guess, the basic exam question, which about decarbonizing the whole energy system. And I think I'd just like to get some initial views from anybody about the key aspects of what we need to do and when we need to do it. So Mathieu, if I can start with you, just your initial thoughts on the whole issue of energy transition and decarbonization.
Yes, thank you, Ian. Yeah, obviously the energy transition is a huge challenge for TSO, and our core mission being responsible for real-time balancing between production and consumption is going to change drastically. Coming from a country where half of the production was made by a nuclear power unit, and we are now facing more and more renewable energy that is being fed to the grid. And for us, we see it as a challenge, sure, but as well as an opportunity, because we see that actually, if we see the right opportunities at the right time, we can manage the cost of the energy transition and we can foster the energy transition. And one of the key aspects I would like to discuss with you today is how we can digitalize the market to make sure that actually it supports this transition. And one of the key aspects in that perspective is it relates to market design, because we see at the moment that we have a lot of difficulties to actually trigger the right behavior, which means that if we do not do nothing, we will have to dimension the grid in a way that it will have to absorb all the production of renewable energy when there is sun, when there is wind, and also when there is none of it, and which means that we will have to rely a lot on interconnection. And by having a right price signal for all consumers, meaning the end consumer, sure, but also small and medium-sized companies, it should trigger the right behavior to use the energy when it's abundant and sparing it in time of scarcity. And in this regard, I believe that we need automatization, because it's for sure not the consumer that is going to be on his iPhone every 2 minutes to make sure that he can charge his car because it's cheaper, because he can heat his home because it's a bit cheaper. So there is a lot to do in that perspective, and we are not there yet. We haven't even started yet. And for me, that's a key aspect that should be tackled in the near future.
Thanks, Mathieu. And I think yes, I mean the challenges, I guess, in terms of the grid, and I'll maybe go to Graeme for this one. So Mathieu talked about that need for flexibility and the balancing, I guess, between supply and demand. What are the key challenges, Graeme, for you as a network operator?
So firstly, it's really important that we're asking the difficult questions, right? Yeah, will the grid cope? What needs to change? I guess a couple of points that I want to make is, firstly, the transition that we're on is not starting today. if we think about the changes that we've seen, we've been on this journey for about 20 years with that transition away from thermal based, typically coal and gas. In the UK, we have more than 50% of our energy demand is met from clean sources, from not burning stuff. So actually, when we think about this transition, it's more about how does the transition happen further, faster. And don't forget, the consumer and business hasn't seen that change in how and where power is generated. What happens when you throw the hasn't then these will be by those who are the consumers of energy. And what that really means for me is to consumer democratization of energy. So I know you don't like the term prosumer. I don't really like it either. The best way I describe it is democratization of energy. We can all now play a part in the energy transition, and some of that automation, from my perspective, is happening already. And then I'll explain what I think that means for grids. So already, dynamic retail tariffs. We have digital APIs that so National Grid publishes the real-time carbon intensity of the grid, and regionally as well as nationally, and with a 2-day forecast. So I already, since 2017, my car charger charges my car when the grid is cleanest and cheapest from those signals, and it matches to the digital API that comes from my energy retailer. So showing by doing is really important. But the other disconnect, I guess, from my perspective is it was a comment you made around that regulatory environment. We need anticipatory investment. Typically seen is regulate for no regrets, and least regrets is the way we need to go forward. And what was actually encouraging for me is in a recent statement in the House of Commons, in the future energy bill, there will be some direction around anticipatory investment. But that anticipatory investment for new infrastructure is not a case of grids. What we need to do is to bring the two together so that we're investing wires to be optimized. Now, that does two things. One, clever digital optimization buys us time to build infrastructure, but the infrastructure that is built not the way grids in the past is to peak plus headroom.
Thanks, Graeme. That's really, really interesting. And I think that how consumers operate within that environment, I think is going to be extremely interesting, and particularly the way they behave. That it's not just about technology; it's about consumer behavior as well. Jenny, if I can come to you, I think you're doing quite a lot to try, or Duke Energy doing a lot to try and help consumers understand exactly what sort of carbon footprints they have. Can you explain a little more?
Of course. I mean, you're talking about the consumer, and it really starts there. We can help in that transition, but energy needs to be used. And so helping the really consumer understand their energy use is really important. So we've built a lot of carbon emissions calculators. We really focus on the large account or the large accounts, your big box retailers and such, your Walmarts, Publix, to show them really what their actual footprint is. And we're using digital technologies to do that, to really see in live time, as well as, in the past, and what we plan to predict in the future as their carbon footprint, and showing them actively how to reduce that carbon footprint. We already have, a 50% reduction goal by 2030 and a net zero carbon reduction goal by 2050. So here's how you can get there by doing nothing. But if you do something, if you are actively reducing your carbon emissions, then you can help us reduce our carbon emissions. And overall, it really helps each other. So having these calculators, having these tools available for the consumers to use is really important. And helping, you talked about us knowing our carbon footprint. You asked me that yesterday. I wasn't able to answer that. And I thought just electricity. I didn't think about driving my car and the food that I eat and the planes that I fly on, but really making consumers more aware of their carbon footprint, where their electricity comes from, is very important in helping overall the carbon reduction goals across the world, really.
Thanks, Jenny. Excellent stuff. And of course, the electricity part is only part of the equation. There's going to be a multi-vector energy system here that we're going to have to get used to, which is, I guess, going to be subtly different to the one that we currently use. And Guro in Norway, you're doing some really innovative stuff in hydrogen.
Yeah, definitely. We've been trying to be kind of a first mover into this hydrogen sector. What we're doing, we're coming from a vertically integrated power company. We're having 100% green hydropower, and we have a lot of run-of-river hydropower. So what we are thinking of trying to do is to see if we can maximize the value of our run-of-river hydropower together with producing green hydrogen. Because what we see now recently is, of course, this increased volatility in the power prices as more wind and solar is coming on stream. And in Norway, at least, we have price collapses during the middle of the day. And in the run-of-river hydropower, naturally, it's not so easy to optimize the production because we need to produce when the water is running by our power plants, while on the contrary, the ones with the storage opportunities can just turn off their hydropower production. So what we are trying to do is that we will put an electrolyzer and produce green hydrogen on our power plant. So when the prices are collapsing, or at least are lower than on maximum, we will produce to hydrogen. And when we are having high prices, then we can produce as normally to the grid. But the problem has been in Norway, and I think many places in Europe right now, is this chicken and egg situation where no one is investing because no one is having opportunity to do the offtake. There are no off-takers. So what we have been successful in doing is establishing a partnership with it's a startup in Norway called Applied Hydrogen, and they will start retrofitting diggers, 30-ton diggers that cannot be run on battery electric, because that is important as well. Point to note that we believe strongly that hydrogen is really needed in the energy transition, but it will be a complement to the direct electrification in the first place and battery electric solutions in the second place. But where they can't be used, then we need to have the hydrogen solutions. So as they are retrofitting their first diggers, they will need a small amount of hydrogen, enough that we can have a proper offtake for a pilot, and not too large so that our board is they're comfortable of taking the investment decisions very soon, we hope. So I hope that we will be, this is a good way of getting this market started. That's our goal.
Good. Thanks very much, Guro. I think, I mean, it's interesting that, hydrogen features highly in Norway, a big oil and gas producer, of course, lots of expertise in terms of producing gas. And Daxita is exactly the same in the Middle East, isn't it? In terms of, your aspirations for hydrogen as a primary fuel vector.
Oh, absolutely. I think, the Middle East, particularly UAE and Saudi Arabia, have stated their intentions to be the powerhouse for hydrogen production and the major global exporter for this green hydrogen. But, just to go back a little bit, we know that hydrogen is still one of the energy vectors in innovation to decarbonize towards the energy transition. But a study was done by IRENA, which is the International Renewable Energy Agency, which stated that to meet the 1.5 degree scenario, this means that clean hydrogen or green hydrogen could only meet up to 12% of the final energy consumption by 2050. So this goes to show that hydrogen is just one element of the energy vectors that supports the decarbonization strategies and net zero commitments. Of course, the renewables plays a big part, blue hydrogen, especially in the Middle East, being petrostate, industries, which is ultimately the bridge to decarbonizing these sectors, which is important. And we see that, with hydrogen these days, water is now becoming the new coal of the future, of course, posing some of the challenges around water scarcity, but we won't go into that conversation today. So there's lots of opportunities when it comes to hydrogen in this market. I know that UAE has a hydrogen strategy already announced, where they aim to ensure 25% of that global low carbon hydrogen market by 2030. So yes, there's still challenges. I think, development around regulations, facilitating financing, ensuring, the demand side agreements are in place, whether it is from government to governments or countries to, within the region, or whether it is those public-private investments and partnerships that are needed to grow this hydrogen industry. We also see that, ENGIE specifically, as part of these pilot programs that we are launching in the region, is we've signed a $5 billion investment with Mazda, where the aim is to produce hydrogen by 2030, and that entails a 2 gigawatt electrolyzer to produce hydrogen, supporting actually the ammonia industry as an offtake. So we are seeing a lot of these pilot hydrogen projects mushrooming or in the last year and 2 years. But we know that, these are really to iron out the challenges that it may pose before it gets scaled up to support the energy strategies of countries.
Thanks so much. That really paints I think a very clear picture as to how far hydrogen penetrates, I suppose, into the network. The sort of 12% that you calculated there, which I think is very similar to a recent report in the UK, which I guess brings me on to the sort of the new systems, the future systems. I mean, clearly we have a national system to be able to, but it also drives, I guess, local systems, local area energy networks. And Graeme, I'd be really interested just to hear your view about, where do those two systems meet, and how do they interact?
Really great question. I think picking up on a couple of points as well before I answer that question. What's really nice from the conversation we've had so far is the realization that the isn't everything, or the answer hydrogen everything. And what we often see is that tribalism. I think we need to, the debate needs to mature. We need everything. And where does that show up? I mean, I think that we're seeing a few things happening. So in the UK, the electricity system operator is becoming a fully independent business over the next few years, that's separate from the wires business. What we've also seen from a government perspective is the regional distribution network operators are becoming distribution system operators. So actually, in the world we're moving into, if you separate the wires from the system operation, you get that purity of how markets can operate, that full independence, which I'm sure is coming. Also, is the fact we need those big national targets. So large-scale interconnection, large-scale offshore wind, large-scale nuclear, large-scale onshore wind. So those will come forward for the volume of energy we require. So that does need big networks. But we also need to recognize the importance of short travel, local energy, local networks, local markets. And what you need is that whole system thinking for that to act as a homogenized energy system. And that's really where we sort of loop back around to that, bringing energy, transport, and digital, energy, heat, and digital. Now, the things that don't change in that is the energy vector and the digital vector. So the ability for there to be that digital innovation to join up the dots. The energy networks, both at transmission and distribution, are built to that peak room, and that peak plus headroom happens for maybe half an hour once a year, which shows that really for the rest of the time, networks are not optimized. And so with that demand management, at least starting at the domestic level, with consumption and charging of cars, that will help that whole systems approach. But one of the things I wanted to point out is I know we've sort of mentioned sort of the growth in EVs in discussions up until now. If we think forward from a UK perspective to 2050, the Committee on Climate in their scenarios, and the balanced scenario is probably the most likely. They indicate the UK will consume probably at least twice the amount of electricity than we do today. That in turn means the need for 4 times the amount of clean generation than we have today. And that means twice the grid capacity than we have today. Now, that's not twice the wires, that's twice the grid capacity. And that will need to happen everywhere. But of that doubling of consumption, what we see is about 15 to 20% of that 100% load vehicle is transport. Somewhere between 60% of that load growth is for heat. And so one of the things I think will be really important is as the decarbonisation of transport moves first, and the smart charging and the ability for EV charging to support the grid as much as be a problem for the grid, how do we quickly apply that into decarbonising the heating system? Because from a UK, 80% of the 86% of the UK is heated on gas, and we will be obviously transitioning away from that as a pure market. And so I think we can't think of this as just electricity, just gas. We can't think of it as electrify or just hydrogen or just electrify. I think it does need that maturity for that whole system thinking, and to take that early understanding of transmission system operation, how it evolves into distribution system operation, and ultimately where we'll probably get to, which is just a one system operator in the fullness of time. I mean, that's a little further out there, but I think, as you said before, there is no instruction book to get to net zero. There's no instruction book to decarbonise the energy system. But at least I know from the UK perspective, decarbonising the energy system is not 2050, it's 2035. So there is a real urgency to learn quick, to take some risk, and fail fast and innovate.
A really clear picture there. And I think, Mathieu, you were talking about this as well, I guess, in terms of how the network operates, the attributes of the network, which I think have got to change to accommodate things like EVs. Energy storage is going to be important, and digitalization, I know, is clearly a key to that. I mean, can you describe exactly how Elia are thinking in terms of the need to digitalize the network in order to enable everything that Graeme's just talked about?
Yeah, maybe to come back on what Graeme just said, we face basically the same challenges in Belgium, because there is clearly a need for decentralization and to have energy produced where it's consumed. But at the same time, the government makes choices where a lot of renewable energy is produced at the same place. Being in the North Sea, where we are about to have 4 gigawatts of offshore wind that will be produced basically in the same place. And for that, we need also a grid that is capable to support such production. So I really agree with Graeme on this one, that we need both legs to actually walk towards the future. And to come back to your question about digitalization, what is important also from a TSO perspective is access to data. It is actually a key aspect to better forecast consumption, because right now it's quite clear where consumption is going to happen and how the grid will function. But in the coming years, we will have to handle much more variation depending on the weather forecast, depending on how much traffic is there on the road and when the people are going to charge their car. And one of the burning topics right now in Belgium is, can we actually have a centralized smart meter data that is available for the TSO and also for private companies, with, of course, respect to the GDPR regulation, but could we actually have a centralized system, both for balancing aspect and for private purposes? And this is also a key that we have to move forward with digitalization if we want to actually go forward.
Oh, I think we've lost Ian. Are you back, Ian?
We
Can
cannot
you hear me
you,
okay?
at least. Yeah, okay, now we can.
Oh, good. Yeah, sorry about that. Lost the connection there. It's typical in these things. That's one of the vagaries of virtual conferences. Mathieu, thanks very much for that. And you touched there on smart meter data as well. Clearly, very important. And Jenny, I know, Duke are doing quite a lot on smart meter data at the minute. Trying to get the information back that Matthew's just described. Could you just tell us exactly what you're trying to do there?
Of course. Well, everyone knows that data is the new gold, right? So being able to have an influx of data, now we have smart meters throughout our 8.2 million customers, minus a few. So having all that data, what do you do with it then? What can you do to understand the grid, the health of the grid, and be able to maybe do demand response or distributed energy resources technology? So taking that information in and then being able to do something with it is key. And that's where digital transformation comes in. And understanding, Graeme was talking about the EVs coming onto the market. That's a big threat right now to our grid that was built in the 50s in the US here. And very small sections have been updated. But really, having this data come in, having this grid now be completely digital, to where from the home to the transmission lines to actually producing the electricity, now we can understand what that entire grid looks like and be able to optimize it, understand the health of each transformer. If you bring 5 electric vehicles into the same neighborhood, can that transformer handle it? So being able to talk back and forth, there's now two-way communication on these smart meters, and we're actually putting digital products onto transformers and onto lines. And so being able to really understand completely what the health of the grid is, then where to invest the money to update the grid per what came back on that digital atmosphere, to show you really what needs to be updated, where you need to focus first. Obviously, we can now tell by doing some kind of analytics, we can now tell actually when neighborhoods are adding electric vehicles to the market, or to the grid. So we're able to really ingest all this information and do something with it, learn from it, and increase the technology, increase the grid. We're able to, harden the grid with, batteries and, like I said, distributed energy. So really being able to take that information in and be active for our consumers, and allowing more things to come onto the grid, and allowing us to update our technology and our grid, obviously.
Thanks, Jenny. And I'll actually stay with you on another topic, which is nuclear. We haven't talked a lot about that, but I know that there's very much a push for nuclear in certain countries, the UK certainly, and the US as well. So Duke, I know, view nuclear as a as a key technology to make that energy transition. So how does that investment look like? What does it actually look like from a Duke Energy perspective?
That's a great question. And as we know, there haven't been a lot of new builds of nuclear within the US, especially in large scale nuclear. I know there are some that are coming online. I think 2 new units in Georgia, but it's been a very difficult transition. We already have operating nuclear facilities. We have several of those. So that really helps with that carbon-free emission. It's very, very important to have that as part of our energy resources there. But really looking into small modular reactors and advanced nuclear reactors is very important to see where that's coming. I know a lot of things are coming on the market in regards to nuclear and nuclear technology. It's so important. It's key to having really clean, reliable energy. I was nuclear for over a decade. I very much support that, especially in our carbon-free emission future. It's really difficult to meet those goals without adding more nuclear, as well as keeping the nuclear facilities that we have operating today on the grid. So being able to convince everyone and help people understand the benefits of nuclear is very important too. So we can look into the small modular reactors, and we can look into the advancement of all the nuclear that's coming on the line today. But if we don't have consumers that believe in it and understand it and can realize the health of really everyone is beneficial with having this clean, reliable energy, especially as we add more electric vehicles onto the grid, and even as transportation, buses, the Amazon packages that are delivered are all now electric vehicles as well. So adding all this new demand onto the electric grid, and then being able to have a sustainable, something that we don't have brownouts, so having that clean, reliable energy is very important. So we're really looking into how can we invest in nuclear in the future, as well as keeping our current nuclear operating online today.
Thank you. That's a very, very clear position, I think. I mean, a great segue from I guess networks onto transport. You mentioned transport there being clearly a large sector to decarbonize. Guro, I know that in terms of the hydrogen that you were talking about, you're also talking about production of ammonia and